The question says that one end of the U-tube containing mercury is connected to the suction pump and the other end to the atmosphere. A small pressure difference is maintained between the two columns. Show that when the suction pump is removed, the column of mercury in the U-tube executes simple harmonic motion. So the case here is, this is a U-tube where mercury has been filled, and one end of the tube is connected to the suction pump, and that is capable of pulling the air out of it, thus increasing the level of mercury on its side, whereas other end is free and open to the atmosphere. Now let us assume that at height h, this is the original position of mercury before the suction pump is applied. Now when the suction pump is applied, the mercury level increases in the side of pump to a level of x. So the total height here becomes h plus x, and the x amount of length of mercury column in the other side of the column decreases. Now we have to show that when the suction pump is removed from this stage, then it executes the SHM. So here we first approach this question by figuring out what is the pressure difference when the mercury column has risen to x in the side of pump. So here the pressure increased can be written in the form of rho gh, where rho is the density of the mercury, g is the acceleration due to gravity, and x is the amount by which it rises on one side. So the total height that unbalance happen is 2x, so it would be rho g 2x. Now according to Newton's second law of motion, we know that force is equals to mass times acceleration. So here mass of the mercury is the total height of mercury, and that is h, 2 times of h, because there are two sides of the column. Now we will multiply it with rho g, so that we use formula rho g h, that is this is the density of mercury, and this is acceleration due to gravity, and so this is gonna be weight of mercury. The mass of mercury can be written in the form of density times volume. Now volume can be written in the form of the area of cross section times the height, so it would be equal to density would be equal to rho multiplied by area of cross section of the tube multiplied with the height, that is 2h. So here h is, here a is missing. Now when we multiply this quantity with g, acceleration due to gravity, then it will become weight. Now we can equate it with the mass times acceleration, where here d2x by dt2 is the acceleration, and this we figured out that this is the mass. So mass times acceleration would be equal to force. Now we know that the pressure difference is rho g 2x. Now when we multiply the pressure difference with air, then it will give us the unbalanced force. So this is equals to the mass times acceleration. Now when we simplify this equation, then we will get d2x by dt2 plus g by h multiplied by x is equals to 0. Now this equation is in the form of d2x by dt2 plus omega square x equals to 0. So actually this is the standard form of differential equation for the simple harmonic motion. This is the standard form of differential equation for simple harmonic motion, where omega is the angular frequency. Now if we equate this equation with the above expression that we have got in 1, then omega will be equal to g by h. So we can here see that the mercury column will execute SHM with an angular frequency of √100 g by h. Thank you.